Okay, good morning Year 5. It's so lovely to talk to you. I hope you've had a lovely weekend and you're going to have another lovely week of homeschooling. Hopefully you'll be back again soon in school, but obviously we're all waiting to see what happens. In good news, we have some lovely weather coming up this week. It should be a heat wave and you are all allowed a bit more time outside now. So hopefully you're going to get to take advantage of that. So I'm here to just talk you through the mathematical talk questions that I've put up on the Frog page. Hopefully you've had a little bit of a go before this video, so it all makes a bit more sense what I'm going to talk to you about. I'll be doing this little sheet here just to explain it to you, and hopefully the camera will be tracking me as I do this. This is very new to me, so we'll wait and see. But yeah, so our first question is, what is the difference between the area and perimeter of a shape? So as I've drawn here and as you're about to see, the area of a shape is the space which fills the shape. So what I'm going to do here, I'm going to colour in area, the space which fills the shape, and then I'm going to colour in the shape to show you all of that. Obviously I would be doing this a lot neater if I was not trying to be quite speedy. All of this space within the shape is the area. Okay, right. The perimeter is the area around the outside of the shape. So if I colour in perimeter in orange, and then what I would do is do the area outside of the shape in orange. Okay, so it's a nice easy way for you to see it. Colour coding things always makes me happy and is quite a nice way and simple way to be able to understand things. Okay, so that's question one. Our area is the space within the shape and perimeter is the space around the outside. Okay, so let's move on to question two. How do we work out the area and perimeter of shapes? Can you show this as a formula? Okay, so here you can see I've drawn a rectangle and I've written area and perimeter above. Okay, we know our area is the space within the shape. So how do we work that out? Hopefully you guys already know this because you have done some work on this today. But our area we find out by timesing the length and the width. Okay, so length will symbolise with an L, width will symbolise with a W. Okay, so area is length times width. Okay, so here that is going to be 3 times 2. Nice and simple. Answer to that is obviously 6 centimetres, and then we put squared. Okay, and remember before we've looked up here, we've seen that our area is the inside of the shape. Okay, so now what we're going to do is we're going to check our answer here. So our area, length times width, is 3 times 2, which is 6 centimetres squared. Okay, oh, I've drawn it incorrectly, haven't I? Right, well this is where we realise that Miss Knowles made a bit of a mistake and we redraw the shape slightly. So here we go. Here is our redrawn line. Let's ignore that bit. Okay, so our shape is here. 3 and 2. So let's check. Have we got 6 squares on the inside? 1, 2, 3, 4, 5, 6. So apart from the little blip of me drawing it incorrectly, we have got the right answer. So that is our formula for working out area. Okay, now we're going to move on to our perimeter. So again, we can see above our perimeter is the area around the outside. It's the orange bit, the area around the outside. Okay, so perimeter here, area around the outside. How we would generally write this is we would do length plus width, put them in brackets, and then put a 2 on that side. That might look a little bit complicated. What this actually means is the first thing we have to do is the thing within the brackets. So that would be length plus width. Okay, so that's 3 centimetres plus 2 centimetres. Which is nice and easy. We can see that that would equal 5 centimetres. Okay, but if we're going to add this up, we can see that that only gives us half of the outside. That would give us 1 centimetre, 2 centimetre, 3 centimetre, 4 centimetre, 5 centimetre. But of course that's not the whole way around the shape. We've still got another half of the shape to go. So that is why it says the 2 here. That means to times the whole thing by 2. So if we go down here, it would be, that means 2 times 5 centimetres. Nice and simple, I'm sure you all know that one as well. That is 10 centimetres. Okay, so let's check this again with our pencil. 1 centimetre, 2 centimetre, 3 centimetre, 4 centimetre, 5 centimetre, 6 centimetre, 7, 8, 9, 10. So we can see that is correct. So there we go. Those are our formula for writing out area and perimeter. If you find that a little bit tricky to remember, don't worry too much, because all you have to do with perimeter is to add up all of the outsides. Okay? If we saw here 3 centimetres on this side, we can see it's 3 centimetres over here as well. We can also see if that's 2 centimetres, this would also be 2 centimetres. So if you don't want to do this whole brackety thing, which is a little bit complicated, you can simply add them all together. So 3 add 2 is 5, add 3 is 8, add 2 is 10, and you come to the same answer. Okay, I hope that all makes sense. Right, our final question, which is a little bit of a problem to solve. Can you have 2 rectangles with an area of 24 centimetres squared, but different perimeters? Okay, so that is our question there. Okay, can you have 2 rectangles, that's what we're trying to do, 2 rectangles with an area of 24 centimetres squared. So an area we know is the inside, okay? And if we look back at what we've done already, how we find that out is we do length times width, okay? So our first thing we have to do is we have to try and come up with 2 numbers that when times together equal 24. Okay, so an easy way to do that is to go through our times tables. So, of course, we'll start with 1 times table. So 1 times what equals 24? 1 times 24 equals 24 centimetres squared. Okay, 2 times tables. So 2 centimetres it would be, times 2 times what equals 24? I'll give you a second to think about it. Okay, 2 times 12 centimetres equals 24 centimetres squared. Okay, so what we're going to do now is we're going to draw those 2 rectangles. If you want to challenge yourself, you can carry on going through the times tables to find different ways that you can make up 24 centimetres squared by timesing numbers together. Okay, but I'm just going to show you this nice, most simplistic way you can do it. Okay, so there we go. I've got 1 times 24 and 2 times 12. So that's going to be very difficult to draw to scale because my paper is quite big. So I'm just going to write it down, but remember I'm not doing it to scale, so we won't be able to count the inside. Let me just check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Definitely not going to be able to fit 24 on there. So what I'll do is I will draw my line. Okay, I'm just doing the little stars in the corner so it's really clear where my corners are, because I know it's a bit more difficult to see on camera sometimes. got a cat in the way. Amber, do you want to move? Okay. So we're going to imagine that this is a slightly different size to what it actually is. That's fine. We can use our imaginations. Tasty tail, Amber. Sit. Okay. So, camera, come back, please. Okay. So our first one, if we remember, is 1 and 24. So one side's going to be 1, and one's going to be 24. Remember, not to scale. Okay. So what we are going to do, we know the area of that, so the inside is 24 centimetres squared, because 1 times 24 is 24. Okay, our next one is going to be this up here, 2 and 12. Okay, so again, not to scale, but you can see it's going to have a larger width and a smaller length. My cameraman's getting a little bit distracted by the cat, I think. I mean, she is very pretty. Okay, so this we're going to have 2 centimetres and 12 centimetres. Okay, so our question was, can you have 2 rectangles with an area of 24 centimetres squared? We'd already figured that out, haven't we? 1 times 24 is 24 centimetres squared. 2 times 12 is 24 centimetres squared. So both have an area of 24 centimetre squared. Okay, we've done that bit, but different perimeters. Okay, so remember our area's the inside bit. Okay, so we've worked that out. That's our pink bit that we coloured in earlier. Area is 24 centimetres squared. Now, do they have different perimeters? Okay, I'm going to show you in the simple way of working out perimeters, which is where we add every side. Okay, so shape 1 and shape 2. Shape 1, perimeter, is the area around the outside, so we add up all of the sides. So we do 24, that's one side, plus 1, that's another side. Okay, then we're going to add another 24. Okay, and then that last one. Okay, I'm doing column method, but I'm sure you can do this in your head as well. Okay, 24, add 1, obviously, that's 25. Add 24 is, come on cameraman, what is it?
50.
Right, let's do the whole column method. 4, add 1, 5, add 4, 9, add 1 is 10, 2, add 2, add 1 is 5. So our total, our perimeter is 50 centimetres for shape 1. Okay, now what we need to do is we need to work out the perimeter for shape 2. So, shape 2, perimeter. Again, we're going to add the outsides. Okay, so our first side is 12. Next one is 2. Next one is 12. And our last one is 2. Okay, column method again. 2 add 2, add 2, add 2 is 8. 1 add 1. So our perimeter for shape 2 is 28 centimetres. Okay, so let's refer back to our question. Can you have two rectangles with an area of 24 centimetres squared? We've done that, but different perimeters. So shape 1's perimeter is 50 centimetres, shape 2's is 28 centimetres. So the answer is yes, you definitely can. Okay, thank you everyone, and I'll see you tomorrow for our next maths questions.